vous avez des questions, n'hésitez pas pendant la présentation. Il y a des grillotines, je vais commander de la pizza pendant la présentation. Fait que, oui.
Pas de la végétarienne, ça.
Ok, de la végétarienne, c'est bon.
Non, non, pas de la végétarienne. La dernière fois, il a commandé 2 végétariennes.
Magasin de claque.
La présentation dure environ 1 heure. Qui s'occupe du jog de Québec? Ben, il y a moi qui travaille pour Cofomo. On a reparti ça quand? Ça fait 2 ans à peu près qu'on a essayé de repartir ça, 3 ans.
Pendant la pandémie, parce qu'on était en virtuel seulement.
Eric, puis Sylvain qui est MIA présentement. Okay. Il y a aussi Alexandre Durand qui est supposé d'être là ce soir.
On va être en retard.
C'est ça. Puis Mère.
Qui check les portes en bas. Ah ben,
Et là,
c'est là.
Donc, si vous voulez vous impliquer au jog, vous pouvez, il y a toujours le site de la communauté qui est québecjog.org. On a un groupe LinkedIn auquel vous pouvez vous inscrire. On a le Slack, si vous voulez, de communauté, si vous voulez aller voir ça. Puis on a un canal YouTube sur lequel on poste une présentation. Si jamais il y a des sujets qui vous intéresseraient ou que vous voulez présenter vous-même ou que vous voulez devenir organisateur, ben, vous pouvez toujours écrire à québecjog@gmail.com, mais le meilleur moyen, c'est de s'inscrire sur le Slack puis de nous écrire là-dessus. Sur ce, je ne vais pas prendre trop de temps parce que je vais laisser toute la place à Mr. Helberg. Here you go.
Thank you. So, hello everyone. My name is Marcus. Very nice to see all of you here. It's my first time in Quebec City, so thanks for hosting me. It's a really nice town. I had a chance to walk around the old town for a little bit, a few hours there. Eric gave me a list of like, you have to do this and see this and do that, and he gave me a kind of maple syrup, so I think I'll be properly Canadian before I leave from here. So today we are going to go on a little fun live coding adventure to learn about building AI-powered applications, specifically in Java, because we are at a Java user group. I'm not a data scientist or AI engineer sorts. I'm a curious person who likes Java and likes to tinker with things. So when AI tools started becoming available, I was very curious to understand, like, well, how can I use these for something more specific to my interests? Because I could really see the power that the tools have the potential for. So this is my dog Nova. Nova is 11 years old. She's starting to become an old lady already, and as an old lady, she has some aches and pains, as we all do when we're getting older. Mm-hmm. And a few months ago, we had to take her in for a CT scan, which is kind of a computer tomography scan, and there's a radiologist that writes up a long, complicated report. And for whatever reason, this radiologist decided the best way of delivering the news to us from this scan was to print out the thing, put it on a table, take a picture with his cell phone, and text it to us with no explanation. So we had a full page of very dense medical jargon, and that we tried to understand, like, what's going on. So me as a nerd, I of course immediately put it to ChatGPT and told it, like, hey, you are a radiologist. Not only that, but you're also capable of communicating with human beings. So please read through the report and explain the key findings to me in simple English. And sure enough, I got kind of 3 headings with a few bullet points saying, like, here's what's happening, and there's nothing really to worry about. She's an old dog and she has some aches and pains. So I was like, okay, that's good. And sure enough, he called 3 hours later and told me the same thing, but that's 3 hours of worrying that I didn't have to do. So clearly there's a lot of very good things we could apply AI for, but at the same time, if you've ever used ChatGPT for something, sometimes you're like, how can it be so stupid? Like, I asked a really simple thing and it's still giving me completely dumb answers. On a very high level, a large language model or an LLM is a fairly simple thing. So you ask it a question, in the middle some sort of magic happens, and then you get an answer. The problem here is that LLMs or language models are generic by nature, whereas what we're trying to do in our businesses or our hobby project or whatever tends to be much more specific to that context. So we need to kind of figure out a way of how do we teach them things about what's relevant to us and our interests for them to be able to give us more relevant answers. So I work at a company called Vaadin. I heard there were a few of you who had used us in the past at some point. What we do is can I get some hands up? How many of you have used Vaadin before? Okay, so half the room. That's incredible. I've never been in a room with such a high percentage of Vaadin users. That's great. I feel at home. Anyway, so what we do is we help Java developers build web applications. Specifically, we focus on helping to build business applications, so more the kind of boring back office applications with tons of data and data grids and forms and validations and charts and this kind of stuff. And in my mind, there is a lot of very inefficient workflows in these applications. People who are spending 8 hours a day in a cubicle here, putting data from one field to another, or doing some kind of manual labor, where I think an AI might be able to kind of consolidate a lot of this work so that the human can maybe more become a kind of a supervisor and just make sure that the work was done, performed correctly, and if not, try to instruct it to do things right. So this got me on a kind of path of like, how do we do this? And specifically because I'm a Java developer, I didn't want to do this in Python or JavaScript, I wanted to do it in Java. So I started looking into the different tools that are available to us and just tried to kind of figure out how to do this. Now, one way of thinking about this that we're going to work on that I think is quite helpful to me, at least as a computer engineer, is modeled by Andrej Karpathy, who works at OpenAI. And he likes to liken an LLM to a CPU in a kind of classic computer architecture. So in and of itself, it's a fairly generic thing. It knows how to perform computations, but it doesn't really know how to do anything more than that. So at a very minimum, what we need when we're discussing with an LLM is a context window. That's kind of the working memory that we have as we're discussing with it. So there we can kind of keep track of our discussion up until then and kind of pass in some information that's relevant for it. Very quickly we come to a point where it makes sense for us to also have some persistent storage, something where we can store things for kind of retrieval later on. So this is usually kind of called a vector store or vector database, where we can store some data that we can fetch when we need it. So if we're interested in getting information, like getting an answer about a specific thing, it's like a library where the LLM can go and fetch the right piece of information to answer that question. Likewise, we probably want to be able to give the AI some limited set of tools so that it can either go into a database and fetch some things, or maybe perform some simple actions for us, so some programs it can run. And likewise, we might in the future want to kind of add on with different things like search tools or even calling other LLMs. So different models are trained on different things. For instance, if you use ChatGPT, you know there's a different model that takes care of generating images because that's what it's trained on, and the GPT-4 model is trained on more like text generation, so it internally calls a different model. And likewise in our tools, we might want to do that at some point. Now, like I said, I'm not an AI engineer or even data scientist or even super good at math, so this is going to be a very much AI for engineers talk, where we're looking at the APIs that we can call. We don't care how the sausage is made, as long as it tastes good. We can call an API and get an answer. That's all good and fine to us. And the tools that we're working with today are LangChain4j. So this is a kind of a AI orchestration library for Java. It initially got started out of the LangChain project, which is a project for Python. And it initially was a Java port of that, but since then it's kind of grown to become, it's taken influences from a lot of other libraries, so now it's not just a straight up port, but it's a pretty useful library that helps us work on a higher level of abstraction when we're building applications. The other tool that we're going to use here is our new framework called Hilla. So what this is a full stack framework, UI framework for Java that uses a Spring Boot backend and allows us to build the UI in React with full stack type safety. So we'll kind of see that when we look at how the app is built, but we're going to focus more on the actual Java implementation of the AI tools in this. I will share the example project source code with you, so you don't need to take copious amounts of notes and try to remember everything that I do. Try to focus more on the big picture idea of like how are things connected to each other and how are we constructing this application. I'm gonna kind of structure this talk along an axis of AI or agent autonomy. So the first time I did this talk, I had this whole fun meme thing that I built out and essentially to say this exact same thing, and then I found on the Microsoft site a much more proper explanation of what I was trying to explain on my own. So there are essentially different levels of kind of autonomy that we can give the AI as we're discussing with it. So at the kind of lowest level, we have a chatbot that's essentially just a generic, it's essentially just a generic chat with an LLM where it doesn't know anything specific about what we're doing. It's pretty much like discussing with ChatGPT with no plugins installed. If we're trying to do something that's more specific to our business or our hobby or anything else, we likely want to go at least to retrieval augmented generation, where we allow the LLM to retrieve some extra information before answering. This makes it tremendously more powerful and useful in providing answers that are interesting to us. If we take one more step, we get to a co-pilot. So this is where we give the LLM also some tools that it can use when it's answering us. So it can perform some actions, a kind of a specific set of actions that we allow it to perform under our supervision. We don't give our kind of steering wheel over to the AI and say, go for it, which is what we would get if we go to the kind of fully autonomous end of the spectrum. Now, we're not going to go there today, and I don't think that a lot of business applications will go there very soon, because we're dealing with pretty kind of important things and we want to have some level of control over what happens. It's not like, hey, can you just do our taxes and hope that it goes well? Like, it seems very scary to me at least. So it's probably good to like let it do its thing, but we're still in the driver's seat and we're able to kind of verify that things are happening the way that they should be. So if we start at the lower kind of beginning end of the spectrum for a chatbot, this essentially translates to our diagram of using the CPU or the large language model together with just the context window. What we want to have essentially at this point from a library like LangChain4j is a way to kind of swap out different models. So if you've been following along at all, you notice that there are new models coming out very frequently, and every successive model is supposed to be much more better than the previous one. There are models that you can run locally on your computer, others that run on the cloud. And it's really handy for us if we can swap out one for another without having to rewrite the entire application. So this is a kind of a bare minimum thing that we want to have. Another thing that's going to be really handy for us to have from a tool is the ability to manage this context window. So if we think about the context window as the kind of working memory that we have available, we need to fit a whole bunch of different things in there. So we need to fit in, first of all, the system prompt, which is similar to in my story about my dog when I told ChatGPT that it should act as a radiologist that's capable of communicating with human beings. We need to have the entire chat history that we have with this, so the actual LLM doesn't remember any of our discussion with it on its own. We need to always pass every single message we want it to remember. And this might become kind of difficult if we start running out of kind of memory. Like, what do we want to do? Do we start leaving out old messages? Do we summarize the discussion? What do we want to do? Again, a tool like LangChain4j can help us manage that without us having to spend too much time counting that. We need to have the actual question that we're asking, and most likely we also want to pass in some extra information that's relevant for answering the question. And what we also need to make sure is that there's enough empty space in this context window where the actual response can be generated. So if we have a, say, 4,000 token window, and we put 4,000 tokens worth of background information there, we would have 0 tokens available for it to actually generate an answer. So we need to kind of keep track of this, and a tool like LangChain4j can make this really simple for us and make it more convenient for us to focus on the actual business problem we have at hand. If you're not familiar with tokens as a concept, they're essentially like subwords that the large language model splits text into as it's processing it. So slightly more, kind of less than a word, more than a syllable. So typically 25% less than the amount of words. So if you have like a 4,000 context window, that's roughly like 3,000 words of English or French, just as an idea. Now, if you've been kind of paying attention to new models coming out, you'll notice that the context window sizes keep growing very rapidly now, from like being around 4,000 with like GPT 3.5 to like 128K with GPT-4 Turbo. It's gone up to like 250K for some models, and now Gemini 1.5 is saying like 1 million context window. The thing to keep in mind though is that we're getting billed by the number of tokens we use, so even though it might become tempting to just like send the entire library of our documentation or whatever for every request, we would get billed by that. So it's probably still wise for us to try to figure out like what's the most relevant piece of information to keep in memory, and not just try to cram the entire context window full of stuff just because we can. It's also super helpful to have a library that's able to kind of do templating for us. So very similar to how we have template languages for producing HTML. For instance, Spring MVC, like Thymeleaf or JSPs. A templating language allows us to kind of populate the template based on some data. And this becomes useful when we have kind of multiple calls chained together, where we want the output from one stage go into the next stage and so on. So that way we have like a structured way of prompting different models. And finally, we want to have a way of kind of easily digesting what we get back from there. So under the hood, there essentially everything just translates to REST API calls, but it's much more handy for us as Java developers to actually say that we want a specific Java object of type whatever, because that's going to be much easier for us to work with. And tools like LangChain4j automate that completely, so we can just say that we want to get back a person object, and it will map, essentially first instruct the LLM to produce a JSON that's in a correct syntax, and then it will actually serialize that into a Java object for us and make sure that it goes correctly. So again, fewer steps for us to deal with, and we can again focus more on the actual business application building. All right, I take a drink here. So the next step, if we kind of continue on the continuum here, is giving the LLM some information, extra context to answer a question with. So essentially we're adding some persistent storage to our diagram here. To understand what's going on here, it's kind of good to know what an LLM knows and what it doesn't know. So it essentially knows two things. One is what it's trained on. This is typically, for the large models, it's like the entire internet up until some certain point in time. The other thing it knows is whatever is within that context window that we send on every request. So those are the two things we have to kind of work with here. So if we want an LLM to learn new things, there are different ways we could go about doing it. Now, if we're billionaires and we have a lot of time on our hand, we could kind of create our own model from scratch. That's rarely kind of needed or feasible for most of us in this room. We could fine-tune a model, meaning that we take an existing model and we give it some extra examples of like questions and answers, how we would like it to answer in certain situations. And this is fairly straightforward operation, doesn't cost a whole lot, and it can really kind of fine-tune, as the name say, a model to be more specific to your business context. But the really cheapest and easiest way of doing this is to just include everything that's relevant for answering a question within that context window. So essentially this is like giving the LLM an open textbook test. So we say, hey, answer me this question, and here's the correct book open on the right page for answering it, and then it can read the source material and answer the question. Typically that gives us vastly more useful answers than if we just asked it without giving this extra context. So that begs the question, how do we know if we have a lot of information? How do we know what's the most relevant piece of information to include there? Again, since we're getting charged by the number of tokens we're using, we don't want to just send everything to the model. We just want to send what's relevant. So in our example that we're working with today, we're doing like a little customer support agent for an airline, and we have a kind of a terms of service document that we're working with. Of course, this is a tiny document. We could very easily just send the whole document, but just to kind of go through the idea of what happens when we're kind of when we're processing information into a vector store so that it's easy findable. The first thing we want to do essentially for all our data is to split it up into meaningful sections. So in this case, I'm going to split by headline, essentially, like into different sections. And once we have that, we're going to perform a little magic trick. So we're going to take this text and convert it into a vector representation of its meaning. Now this was something that was really weird to me the first time I saw it, like how does that even work? So again, like this is not going to be a 3-dimensional vector, it's going to be more like a 1500 to 3000 dimension vector. But what it captures is the meaning of this text, not the semantic value. So it doesn't matter if it's in French or English, the vector value will be pretty much the same. So it's trying to capture that meaning. Now this is really weird, so the one way that I've kind of helped people understand this is by using an analogy of a color picker. So if you've ever used a color picker, you know that you can essentially select any color value in the whole spectrum, and you get a 3-item vector representation of that, red, green, and blue. Intuitively, we know that similar colors have very similar vector values, whereas different colors have very different vector values. Now, when we only have 3 values in the vector, it's very easy for us to kind of understand what the similarities are, because one is like how similar are they in red, and one is how similar are they in green, and so on. But what we're doing with these vector embeddings is essentially the same for text. And that's why it's really important for us to meaningfully split our source content, because otherwise if we were just sending this entire document and doing one vector embedding on it, that's like asking our color picker to say what's the color of this entire picture that we have. Surely it could probably get some sort of like median value of all the colors on that picture, but it's not nearly as useful as saying like what's this red color on this can, which would be a much more specific question to ask. So if we can figure out a way of meaningfully splitting these things, it's going to give us much more meaningful answers when we're querying.
And is LangChain4j helping us being able to split that in meaningful information? Or
so it's helping us in the way that it's so what actually takes a text and converts it into a vector is called an embedding model. So there are different models. In our case, we're going to use just one that runs locally on our JVM. It's not a particularly fancy or good one, so you like in a real life application, you'd probably want to use something like OpenAI's API for that. But essentially, the API that you call takes in a string, gives you back a vector. And that's kind of the API level description of how those work. Now, I mean, on a deeper level, they're essentially kind of weights from the actual like neural network. So there's a model that it runs through, and then it kind of picks the weights from the sort of the next to last layer of that network. But that's way too deep for this talk. All we need to know there's an API that we can pass in a string, and we get a vector that represents its meaning. So that's pretty cool, and that's probably like if you're super interested, there are a bunch of YouTube videos going into much more detail that I'm capable of explaining here. But what we want to do then is when we have our text, we have the vector representations, we want to put those into a vector database. So vector databases, just a specific type of database that's good at vector math. There are extensions for Postgres, for instance, so you can use Postgres for this as well, or Redis, or all kinds of different databases have support for vectors these days. What we want to do then when a user comes along and asks a question is that we use that same API to pass in this question, and we ask what's a vector representation of its meaning. Then we can query the database to ask like, hey, what are the most similar pieces of text that we have in the database to this question? And since this has to do with cancellation, its meaning is somehow related to cancellation. I don't know how it's represented in 1500 dimensions of an array, but it is somehow. But when we ask this vector database to find the most similar meaning text, it will give our cancellation policy back from there. So now we're able to just kind of take the right piece of content, put it into that context when it's when we're asking the question, and it's going to give us a very great answer. So in my case, the first retrieval augmented generation app that I built was, I took all the Vaadin documentation. Essentially that was in ASCII docs, so I was splitting it by headlines because I figured that's probably going to be pretty meaningful sections. Fed it in there, and then I asked the question. And what it actually did was that many times it didn't just like use one part of like the entire like one page of the documentation, but it found the right sections of like 4 different pages and included those, and it gave really like surprisingly useful answers like right out of the box. It also helped me realize some really stupid mistakes in our documentation, because it's also like if you haven't like specifically said something in your documentation, or if it's wrong, it's also going to be wrong. So so there's that. Yes, sir.
Does LangChain4j handle overlapping of chunks?
What's that?
Sorry. Does LangChain4j handle overlapping of chunks and benchmarking to know which chunk size is optimal? Things like that.
I don't know if it has any automated way of knowing what is like the optimal size of this split, so that at least for me has been more of a trial and error thing. And you can, so it supports different pluggable document splitters, as it said. So in what we're going to use today is just a recursive splitter that essentially tries to fit entire paragraphs into a given size. If that's kind of too large, then it'll split it by sentences and so on. I found it, like if you have a structured format, like say Markdown or something, it's quite easy to kind of find more meaningful sections of text, because the author has already gone through some of the trouble of doing that. And like you said, you can also say how much these chunks should overlap. So sometimes it makes sense to have them slightly overlap each other. So if you're kind of cutting off something in mid-sentence, essentially, you have a better chance of having one of those kind of be a complete. Anyway, we'll get back to that when we get to the actual code here. The final kind of part that I want to cover here before we get to the actual fun part, which is coding, is Copilot. So this is essentially us adding some tools to the mix, so allowing the LLM to perform some actions for us. So when we're using tools, we, one, don't want to just give access to our entire system, like go at it, like just here's my database, just figure things out. We want to be very specific about like you can use these 3 methods and nothing more in helping me. And of course, when you implement those methods, you need to put some very strict kind of checking on what's happening so that it doesn't try to do anything crazy. But giving tools to the LLM can vastly improve its usability, because now it can like do many more steps on its own than it could if we just if we didn't give it tools. Good. And so I was supposed to update this, but I forgot. So I got a question in my previous iteration of this, like how does it work? Like does the OpenAI actually call methods on my computer? And no, that's not how it works. So the way this works essentially is that when we do a call to OpenAI in our case, it's going to send along with the request a description of like, hey, here are 3 methods that I have available. If you need to use any of these in answering, let me know. and then LangChain will run those locally on our computer and send those back. So in that case, it goes kind of back and forth 2 times to the LLM before we get an answer. Anyway, I wanted to give you a little bit of theory because I don't know where everyone is on their AI learning journey, so that when we start coding, we can all kind of follow along with what's happening in code. What we're going to build is a little customer service agent application for a hypothetical airline called Funair. And what it should be able to do is answer some questions that are kind of grounded to our terms of service. So if we ask about cancellation policy, it should be able to explain exactly what that is. It also has access to our database to kind of pull information about bookings and make some trivial changes to them, like where the destination is, or cancel them. If the user tries to do that, it should try to apply the rules in those terms of service. So if you're within a certain time window before the flight actually leaves, you're not allowed to cancel the booking, whereas if you're further away, you can. So we're gonna just kind of make a somewhat realistic application. Now I know we're in Canada, and I read about the case with Air Canada and their similar chat agent running into trouble, so please don't take this and put it into production right away. If you do, don't blame me. But we're hopefully going to be able to build something pretty cool and useful and not super much time, and you can then kind of use this as a base for whatever else you want to build. Again, I'm going to share the source code of this application, so pay more attention to like what it is that we're doing and the big picture things. The other thing is, like I mentioned, I'm super jet lagged right now. I was last week in Finland, the weekend in California, and now I'm here, so even my jet lag has jet lag at this point. So I might be doing some stupid things, so you need to stay awake and tell me when we're going horribly wrong and get us back on track. All right, so here's the live application. Right now, if I say something like, hey, it's going to say, hello there, my brain is not hooked up, sorry about that. Can you see this on the back row? Okay, make it bigger?
Yeah.
Yep. And let's make sure the code is also okay size. Good. All right, so this is what the application looks like right now. Of course, it's saying that the brain's not hooked up, so we need to start with that. But before then, let's take a look at the actual project that we have. So here I'm using the Hilla framework, as I mentioned. So what we have is a Spring Boot project where I've added a couple of dependencies. So first of all, the bottom Spring Boot starter that allows us to build a full stack application where we have a React front end and a Spring Boot backend. Then we have Spring Boot DevTools that's going to live reload some changes as we make changes to our code. And then we have LangChain here. So I have the LangChain Spring Boot starter that allows us to do some pretty cool stuff in a more kind of Spring Boot way where it auto-configures a lot of things for us. Then I've added specifically the OpenAI starter because we're going to be working with the OpenAI model. If I was working with, say, Google Gemini, I could change this to the Gemini model and everything else would just be the same and we wouldn't have to change our code. And then I'm using a embedding model. So this is the model that takes a text in and returns a vector. So in this case, I'm using a embedded model that runs on my computer. If I left this out, it would be using the OpenAI model instead. All right, so that's what we have. If we look at the actual project code that we have, you can see that we have our classic source main here. We have in the Java project, or Java folder, we have our Spring Boot application. I have a simple model here with bookings and customers. Nothing too exciting, so I'm not going to go through any of those. In the service package here, I have a flight service, so this is what I can use to fetch information about the existing bookings in the database. It's going to return booking details, which includes booking number, first name, last name, dates, and so on. And what's interesting here is in our client package here, I have 2 services that are annotated with a browser callable. So this is specific to Hilla. This allows me to call this Java service from TypeScript as a method with the same parameters. So the assistant service is what we're going to use to call the AI assistant. Right now it has one method called chat, which returns a flux of strings. A flux is a reactive data type that we can subscribe to, so as new data becomes available, we can pass that along. So with AI models, there are essentially always two different APIs we could use. One is a blocking API where we wait for the LLM to complete the entire response and then it sends over everything at once. That works okay if we have short answers, but for long answers, like if you ask it to, I don't know, write a song about something, that could take half a minute maybe, and it's not really fun to just leave the UI hanging for that long. So we're going to use the streaming API where as things are generated, we can display them to the user right away, and that makes it a little bit more interactive. If you use ChatGPT at any time, you know sort of the kind of user experience we're going for here. The other service here is just for us to get the current state of the database. So we just have one method here called get bookings, and it just fetches all the bookings in our database so we can display them here. The UI is in the source main front end here, and the only relevant file here is the index.tsx file. And as you can see here, we have a split panel with a grid on one side. We have the messages and the message input here. So how that looks in React is we have a split layout where on one side we have, essentially we map over each message and display it. We have an input, and then we have a grid here. Again, React isn't the topic for today, so I'm not going to go through this in too much detail. What's interesting to see here though is that we're mapping the messages here, and we've bound the bookings here. So in React land, how things work is that we have a state and the template, which is then kind of a function of that state. So we have our bookings and messages defined up here, and essentially anytime that we finish a call, this effect here will essentially call the booking service to get the updated state of our database, and that's going to update it into the grid. When we send a new message, what we do is we add first the message that we sent ourselves, and then we call this assistant service.chat. So exactly the same method signature that we have here. We subscribe to it, so we say on the next chunk, so essentially, I guess I could call this token. Token would probably be a better name. So whenever the next token comes along, we're gonna kind of first, if it's the first token, we're gonna add that as a new message, and then as new things come along, we just append the rest of the response to that same message. So again, if we look at how that works in real life, if we say, hey, it's gonna append those tokens to the message. All right, so we'll close that, and we're going to focus all our effort now on the Java side of things. So the first thing I want to implement is a interface for the AI assistant that we want to have. So very similarly to like in Spring Data, you define a JPA repository interface, and Spring Data then provides the implementation of that. We'll define an interface, and then LangChain4j will provide the implementation of that. So for that to work, we need to add a AI service annotation here, and then we provide the actual interface that we want. So let me actually turn off Copilot here so it doesn't confuse us. So I'm going to return a token stream. So this is essentially the streaming API. We will get one token at a time, and we're going to call this chat. It's going to get in a string, which is the chat ID, and a string, which is the, let's see, user message, like this. And this should, of course, be an interface, like I said. Okay, so I'm going to give some annotations here for LangChain to understand what's going on. So this will be our memory ID. The memory here refers to us keeping track of different people's chats with different keys. So we'll have a unique key for each chat that we can then track separately. And then we'll just say that this is the user message, so that's the actual message that the user sent. Okay, so I'm going to save that. I'm going to go into my assistant service. So this is again the client or the browser callable service. I'm going to create a private final assistant here. We'll call that assistant, and we're going to create it as a constructor parameter here. So this will cause Spring Boot to auto wire this in, or I should say Spring DI is going to auto wire this into our application that we have this assistant. Now, the token stream that LangChain4j uses is not a standard Spring or Java data type, so we need to do a little bit of mapping here. I've been talking with the maintainer of the project, and he is adding support for just returning a flux directly. That's not there today, so we're going to do the mapping ourselves. So the way we can do this is by using a sync, which is a programmatic way for us to create a flux. So this is a little bit of boilerplate, but hopefully not too much. So we're going to create a sync that returns many strings. Call this our sync. And we can use syncs.many. Okay. So what this means essentially, we are broadcasting to one person, the person who made the call, and if for whatever reason we're generating more content that the client is able to handle at any moment, we're going to buffer those instead of dropping some random words in the middle of a sentence, because that would be super not helpful for what we're trying to accomplish here. And then we're going to return that sync as a flux. So what we need to do here in between then is we need to take the assistant method that we have that returns a token stream and convert that into calls on this sync. So I'm going to take the assistant and call this chat method on it. Has the exact same signature, so I'm just going to pass in the chat ID that we get from the client and the user message that we get from the client. And I'm going to say on the next token that comes along, we're going to call sync.tryEmit next. So we're just passing these along through. Then on complete, we get an event here, and we're going to call sync.tryEmit complete. And then on error, we can do sync.tryEmit error. So as you see, the APIs are almost identical, and it would make a whole lot of sense if they could add the direct call to return a flux. But as things stand right now on version 0.3, this is what we have to work with. All right, so we have this. If we now go ahead and build this project, so I'm going to go here and build, or I'm going to use the keyboard shortcut here instead. This is going to automatically rebuild the application, and if we call this now, it should not say that its brain is not hooked up. It should hopefully say something more helpful. So, okay, so hello, how can I help you today? Who are you? So let's see if it knows who it is, because it's an AI developed by OpenAI. Okay, so we haven't defined the system prompt yet for it to kind of explain who is this chat bot that we're specifically working with. So let's go ahead and define a system message here, which is going to define or allow us to define who this particular assistant is. So for that, I already created the prompt here, so we don't have to type it out. Looks something like this. So you're a customer chat support agent for an airline called Funair. Respond in a friendly, helpful, joyful manner. Before providing information, you must always get the following information: booking number, customer first name, last name. Before changing, you must ensure that it's permitted by the terms. If there are any charge, you must ask the user for consent. And then we pass in today's date, because again, the LLM is generic. It doesn't know what date it is if we don't explicitly tell it. All right, so let's go ahead and build that and see what happens. So let's go ahead and ask who it is. Okay, so now it's saying that it's a cheerful assistant from Funair. So now we've given it a personality, knows who it is. Okay, good thing. So I'm going to use the dictation here just because it saves me a lot of typing, but helps me kind of show some things. So, hi, my name is Marcus. So right now we haven't really hooked up everything we need here. So if I now ask what's my name? I forgot it. So, what an adventure we're on today. Let's solve this mystery together. So now it's trying to be very helpful and kind of skirting the fact that it doesn't remember what I just told it. So instead it's like, well, if you give me a booking number, maybe we can sort it out together, which is of course not what we want to do. So let's go ahead and give this a memory. So essentially tell LangChain4j how it should manage this context window for us. So I'm going to create a new class here for just configuring LangChain. So let's say LangChain config. This is going to be a configuration class. And the first thing we're going to define is a bean that returns a chat memory provider. This can be just chat memory provider like this. And what I want to return here is a function that takes in a chat ID. Again, that's what we passed from the client. And it returns a token window chat memory with, let's say, 1,000 tokens is how much we want to use for the history here. Needs a tokenizer, so we're going to auto wire that in. Tokenizer. So tokenizer essentially is able to count how many tokens a given piece of text is. So we'll just pass that in like this. So if we build this right now, we should have hopefully given our AI some more capabilities. Hello, my name is Marcus. All right. What's my name? I seem to have forgotten it. Okay, so now, since we gave it a specific memory now, we're telling it how to kind of keep track of discussions. Now it's able to remember that I am, in fact, Marcus. So that's good kind of start here. But again, we're still at that chatbot phase on our kind of progression here. So it doesn't really know anything specific about our company besides that it's an agent that's funner. So if we ask, say, can you explain the cancellation policy to me, please? So if I ask it something that's more specific to our information, it's gonna give us something that sounds super credible because it's probably based on all the cancellation policies of every airline out there. So it sounds very compelling, like this probably could be correct. The only problem is that it doesn't have anything to do with the actual cancellation policy that we have in our terms of service here. So the next step we need to do is ingest this document. So walk through those same steps that we did on the slides to put these kind of sections of the text into a vector database that it can search. You had a question back there?
Yeah. Can we define in the config the way it should truncate the context when it reaches the end?
Yeah, so the question is like, what should happen when you actually hit that 1,000?
Yeah.
So
So
with the token window, with this token window chat memory, it's just going to start dropping off older messages. This is an interface, so you could provide your own implementation where you could summarize or do any number of things that you wanted to do for that. So what's super nice with a tool like LangChain is that all of these things are interfaces where you can provide your own or swap out different implementations as you see fit. So in this case, it's just going to start forgetting things. So very much like ChatGPT used to be back in the day, where like 20 messages in, it would start to forget all of what you were trying to do.
So by default, it will remove the system prompt, or it will keep it?
The system prompt will always be there, but it will start dropping older user messages. All right, so where were we? Okay, so yes, we wanted to make it aware of our specific documentation.
So we'll drop older on the order that been entered or on the number of times it's been used?
It's always going to drop the older.
The older?
Yeah, because it's always sending the entire history on every time we call OpenAI, we send the entire message history. So I had a gentleman in Chicago who asked the question, like, OpenAI has this agents API as well, where essentially you're offloading some of this work to kind of their side of the API, where you don't have to always keep sending the entire chat history with it. We will manage it kind of internally, but for learning purposes, this is kind of good because we kind of have all the pieces in our own hands here. All right, so the next thing we're trying to do then is like, how do we make it aware of our terms of service here? So for that, if you remember, we need the model that takes in a text, returns a vector, then we need a vector database where we can put it, then we need to actually go through all the steps of getting that document from our class path and put it into the vector database, and then we need to tell LangChain how to actually fetch it from there. So a little bit of coding, but nothing we can't handle here. So we're gonna create a bean for the embedding model. So the embedding model is what takes a string, returns a vector. We're gonna return a new all mini whatever embedding model. So this was the dependency that we had in our POM file. Then we're going to have a similar one for a embedding store. This is going to be an embedding store that has text segments. So text segments being just segments of text. And here we're going to return a new in-memory embedding store. So again, we're just doing everything in memory here. But because these are interfaces, you could swap these out for, like, this could be the OpenAI embedding model, which is vastly superior in every conceivable way. But again, it's overkill for our tiny document here when we're trying to learn. Likewise, we could swap this for Pinecone or Postgres or any other database that we're actually using in our application. Yes, sir?
Is there a kind of standard that is emerging from the industry as those interface for the models? Or those are just like you guys that have created those for LangChain4j?
So these are not created by Vaadin or even LangChain4j. These are just independent of both. So there are different companies and projects who are creating models all the time. The only thing to keep in mind is that you need to use the same model for when you're ingesting the data, so when you're creating the vectors into your database, as when you're asking questions. Because if you're using different models, the vectors that describe the meaning will be of different. So one might be like in our color picker example, one would be an RGB vector and the other would be a GRB vector, for instance, and they wouldn't be compatible with each other. So then what I'm going to do is I'm going to ingest the documents. Now, typically in a real world application, you're not going to parse all the documents in the same app that uses them. You have a build server that whenever your documentation changes, you go and only update that. But for us to build a self-contained example, we're just going to do all of this here. So I'm going to define an application runner. Docs to embeddings like this, and this is going to return a function that has arguments. Here we need to get a couple of things auto-wired for us. So first of all, we need the embedding model, so we know how to turn strings into vectors. Then we need the embedding store of text segments so that we know where to store them. Then we need a tokenizer so we can count how many tokens different texts are. Then we need a resource loader, let's call this loader, for actually pulling that document from our class path. So let's start by just getting the actual document. So I'm going to call this our resource by calling loader dot get resource class path terms of service txt. And we're going to get the actual LangChain document based off of that. So we're going to call this our doc by calling load document, and let's see here, great, let's try it again. So this is getting now statically imported from the LangChain4j loader, so there are different loaders. There's a new convenience loader that essentially allows you to just point it at a folder and then look at the file endings and try to figure out how to load every single document in there, which is probably great for demos where you don't need to teach how things work. But here we're doing every step, just so we understand kind of how things work. So we're gonna load the document. So this takes in two things, the path and the document parser. So the path we can get from our resource file, so we just turn that into a path, and then we create a new text document parser like this. All right, so the next thing we need is an ingester. So the ingester essentially just takes a document, it splits it into sections, it turns each section into a vector, and then it puts it in a database. So we're going to call this our ingester. This is going to be embedding store ingester, and it's using a builder here, so I'm just going to close the builder first, and then we're going to go in here and say that our embedding model will be our embedding model, our embedding store will be our embedding store, and then our splitter, which actually takes that document and splits it into different ones. We're going to use a recursive splitter here, and let's see if we can find that. So again, this is from the document splitters import in LangChain. This takes a couple of parameters. One is like how many tokens should each segment ideally be, how much should they overlap, and what's the tokenizer, so how does it actually count what a token is. So for this we're going to use the magic numbers of 50, 0, and tokenizer, because we happen to have a very short document with short sections, so I have...
what's the overlap used for?
So say if you have like a, I don't know, long code sample or something, it might get cut off in the middle, so if you have an overlap you might have a better chance of like fitting the whole thing into one. So sometimes, especially like, it kind of mitigates the problem of sometimes cutting things in half if you have like a little bit of overlap. So I haven't found any like academic way of figuring out what the right values should be here, more like try running it and then have a discussion with it and see if it's helpful or not, and then retry this. The embedding models are remarkably cheap to run, so it's perfectly fine to kind of do the engineering approach. So even when I did this a year ago for all the bot documentation, like 400 pages, it cost me I think like 48 cents, and since then it's probably come down by 2 orders of magnitude, so it'd probably be like less than half a cent at this time to run all of those, so it's quite cheap to do those. Okay, so again, this is quite a lot of work just for this one document right now. So the idea here is we're learning. This is not necessarily like, if we had hundreds of documents, this would still just look the exact same. So we're doing quite a lot of upfront work just for this one document, but we can just now tell our ingester to just take in this document. It'll then split it up, take each section, turn it into a vector, and store those in our vector database. So we're gonna ingest our document here. So once this gets run, now hopefully our vector database contains all the vectors that we need. So what we need to do then is make that information available to LangChain. So we're gonna create a content retriever, which is kind of a plugin for LangChain for telling it how to actually retrieve that document. So we're going to call this retriever, and this needs to take in our embedding model again, because when we ask a question, it needs to be able to take that question and turn it into a vector. Then we have the embedding store, where it can go and find things. So that'll be our text element embedding store. And here we're going to return a embedding store content retriever. We're going to use a builder here again, and we're going to configure first of all the embedding model, be our embedding model, so it can turn those questions into vectors. Then we're going to tell it where to go and find those. Embedding store. We're going to say that we want, in our case, 2 results, and the minimum score of each result should be 0.6. So these are, again, values that you definitely want to play around with. LangChain supports more advanced RAG features too, where you could fetch documents for all kinds of different sources and then run a re-ranking to say like which ones are the most relevant out of all these. things that I found, but for now, we're just gonna say that we want 2 results and they should be at least remotely relevant. So one being 100% exactly the same, or 0.0, like there's nothing common between these, so somewhere in between. Alright, so let's go ahead and build this and see if we are on the right way. So hopefully now, if you remember from before the pizza, we asked it about our cancellation policy. It made up a whole bunch of plausible sounding but not correct information. So if we now ask it, hey, can you explain the cancellation policy to me, please? Let's see what it says. Alright, so cancellation window, 48 hours before your scheduled departure, fees. Alright, so now this is actually mapping exactly to our cancellation policy. So we have the different fees and the cancellation window and everything explained to us, formatted nicely with markdown and everything. So much more useful. Good. All right. So we've now kind of gotten all the way to the retrieval augmented generation part of our autonomy scale. Let's take that one step further and give it a few tools that it can use to actually access our database and perform some simple operations for us. So what I want to be able to do is, as a user, be able to pull up my reservation, make changes to it, and cancel it. And of course, cancellations and changes should be according to our terms of service, so only allowed things should be actually allowed. All right, so for that, we're going to create a new class. We're going to call this our booking tools. This is going to be a Spring component, and it's going to take in the flight service, so that's what we use to actually fetch information from our database. I'm going to do a private final flight service. That we're going to inject it. So I want to have a couple of methods here. So the first one will be a public booking details. Again, that's the record that includes all the information about a single booking, called get booking details. This takes in the 3 things that let's go see, where's our assistant. So as you remember, we said that we need to always have the booking number, first and last name, so we need to take in the string booking number, string first name, string last name. So at this point I'm going to turn on Copilot to save you from watching me type a bunch of stuff. So we're going to return by delegating to flight service. We're going to do a different one. Let's see if we can get public. We're going to cancel booking string. Let's need to go and change this a little bit. Booking number. Alright, that looks better. And then finally we want to have something that cancels a booking now, or changes one. So Copilot tried to come up with an API. It wasn't exactly right, but it's close enough, so I'm just going to essentially have the same exact API here, like this. So in order for us to make these available for LangChain to use, we need to annotate them with a tool. We could add in a description of what this does, and we could add annotations here for each parameter if we wanted to give more information about what they should include. For right now, since we were very explicit in naming variables, it's going to work with just saying that these are our tools, like this, and building this. So hopefully now that we build this, it's going to pick those up, and we should be able to do some magic here. So the way I made up the test data here, John Doe is too close to his flight to be able to cancel a booking, whereas these people towards the end of our data set should be able to change there. So let's start by saying, hi, my name is John Doe. My booking number is 101. Can you please pull up my details? Let's see if we can get anything. All right, so I was able to pull up our details now from the database. So it called that function. Again, the way this works is that when we call OpenAI, it tells OpenAI that, hey, here are some functions that you're able to call if needed. and then OpenAI will send a reply saying, okay, please get booking details with this information. LangChain runs that locally in our application, sends the response, and then OpenAI generates the final response. All right, so that's good. Let's see if we're able to cancel it. Can I cancel my reservation? Okay, so given your booking is today, same day, not allowed, needs to be 48 hours before the flight. So again, we could probably tweak the prompt to be less verbose and like get to the point quicker, but it sort of worked for what we wanted to.
How would you do that? To make it shorter or?
So we could go into the system prompt here and try to give it some more, sort of like so respondent friendly. So we could try to be like respond shortly and don't like yeah. So you probably need to like try to tweak this to both like sound the way you want it. Like if you wanted it to be more realistic, you should say like be sarcastic and like angry and. What's that?
Is there a humoristic module where it does jokes or whatever?
Yeah, you can, as long as you tell it like you like wordplay and bad jokes, it will throw those in there, and anything, it doesn't matter. Okay, so let's reload here and see if we can. Let's pretend we're Robert Taylor, and this time I'm not going to give it all the information up front. So let's see if it's able to kind of. I'm a real human being. I'm not always going to give all my information up front. It needs to ask me for some details. So. Hi, my name is Robert Taylor. Can you please pull up my booking? So it needs the booking number. Okay, so we have in a prompt that before it can do any of this, it needs to have all those three. My booking number is 105. Okay. Okay, so now I didn't have to re-ask for my name again because it remembers that from the memory. I was able to find this.
How about security? Let's say you have different type of users, and some you don't want them to know the flight from other people, but other people might. Is that all described in the little app?
I wouldn't leave any kind of security up to the LLM to try to get that right. That should probably
do you want to? Do you trust the LLM to?
No, what you could do is when you ask for something, you can add another filter to make sure that it matches the token you're authenticated with when you query the database. So the document that come out only matters to you, then whatever you ask the LLM should only matters to you.
Yeah.
Okay, that's one way, but yeah, no, it's good. L'instant de sécurité plus dynamique, tu vas le décrire, tu sais, on peut appeler if else. Dans ta description, tu peux dire certains types de personnes peuvent voir les bugs, d'autres systèmes employés. Là, c'est pas juste si c'est toi, là, c'est un rôle.
Non, je comprends, mais là, ce qui passe, c'est un RAG. C'est que là, il y a une première requête qui va t'appeler et qui sort le record. Ce qu'il envoie à OpenAI, c'est juste le record straight avec le prompt. Mais ce que tu envoies, c'est toi qui contrôle ce que tu envoies. Ça, tu le contrôles, puis c'est pas une monnaie d'OpenAI.
So,
sorry.
No, that's fine. So what I would probably do is that before you're able to, like, if this were a real thing, like, before you're able to pull up anything, it should say, like, hey, you need to be logged in first, and then, so for instance, it would check that, are you logged in, and then you log in, and then you pull from the session, whatever, and you only query with that. So this is horrible security.
Yeah, well,
because
I just built that thing, but for like another company, and people were asking for like delivery or tracking number. So they didn't want to send information about the others tracking, but only for yours. But it's the same thing.
Yeah.
Google Query Database. When I shipped a 3M camera, whatever. So when should I get it? I need to know who you are, I need to query the right information, then give that to the LLM, and then I'll get the answer. But then, yeah, it's the same thing.
Yeah, so, I mean, yeah, I guess it's like, even if you like have a, like if you call somebody, like they'll ask a few set of questions, if you're confident enough that if you answer the right questions that they're the right person, if it's not super high security, maybe that's enough.
But
For others, it's probably good to like have a actual authentication.
But that's also valid, because on the other end, if you don't put any validation, I could ask, oh, there's no like cancel James ticket for that matter. We'll do it, because
Yeah. Alright, so let's see, hi, my name is Robert Taylor, my booking number is 105. I would like to change my flight to Quebec City instead. I hear it's beautiful this time of year.
not really beautiful.
Yeah, it's a little bit.
Should go to Houston today.
So, could you please confirm the new date? Same date. So let's see. Alright, so now we're, so again, we didn't have to like figure out what the airport code was and stuff, so.
So can you put any guardrails around it? Because technically you ask, I'm just making this up, but you asked to go to Quebec City because it's nice. But it could have, technically it could have said that it's way better in Houston. So how could you guardrail whatever it's going to be answering back?
So it's very hard to guardrail anything that the LLM does. You can certainly try in the prompt, but like anything that's actual business rules, you need to do programmatically. And obviously, like here, since it's likely going to cost it, like the cost difference would be like more than whatever the change fee is here. So you'd have to like also figure out like what's the cost of the new trip and everything. So not super realistic in this case, but.
Because I got a really, funny requirement for that matter. It's a company that sells stuff. And the requirement was, if somebody searched for something and you don't find anything, we don't have any replacement, make up stuff. So I was like, well,
well, that's something that LLMs are
you
good
get a
at.
competitor product for that matter, right?
Well, that's interesting. Yeah. All right, so let's wrap this up and we can continue. Actually, I talked to some folks here and they said it's actually not that nice here this time of year, so cancel my trip. Okay, so now we're not going to get it. All right, let's see, where are we? All right, so we built that application with Pizza Break. It took us 45 minutes. Of course, it's a kind of a demo app, but hopefully it showed you more of like how could we integrate AI as a part of the business processes that we're doing, so that it's aware of the actual context that it's working in, so we can do something that's more meaningful than just having a generic back and forth chat with a LLM that we could have with any open model out there. This particular playground is slightly different from what we did here because it has a Spring AI and LangChain4j implementation, so you will get both kind of in the same package. I'm still trying to figure out how to get Microsoft Semantic Kernel in there. I might need to split out each library into its own branch because there are quite a lot of things on the class path that clash because they all have a class called tokenizer and they all have a thing called something, and with auto wiring that has run kind of gotten me into some trouble. But anyway, the only thing you need to run this is an OpenAI API key, so if you have that in your environment, it's on the README, so just put that in your environment and you can play around with this locally. And with that, I want to thank you all for coming, for having me in your beautiful city, even this time of year. No, it's
getting
been,
better.
It's been super nice. Like it was a little windy this morning, but like it didn't rain on me. whether like snow or water or anything in
There was
between.
snow last night. Maybe
Yeah.
not downtown, but
Anyway, if you have questions, I'm happy to take them here, or then I post my laptop and walk around and answer questions.
if you want to use French or to chat, how good is that? How do you?
So yeah, that's actually a really good question. So that was like a unintended consequence, like when I did our, let's see, Vaadin. So when I created my Vaadin docs, this is a slightly outdated one, so don't use it. But what I realized is that even though all the documentation is in English, all the kind of prompting, everything I did was in English, I can still ask like something in, say, Finnish. And of course you don't know Finnish, so you don't know if this is true or not, but I can assure you that this is perfectly fluent Finnish, so it doesn't matter what language you actually use for asking it, so that is a pretty cool thing. And again, like the vector embeddings, because it's capturing the meaning of that text, not like what the source language was, it doesn't matter what the initial language was that we asked in. Yeah, so yeah, this is all in Finnish here.
Attendez, peut-être trop petit.
Yes, sir.
So how does that integrate with Hugging Face and open source models?
So if we, so there's you would use a Hugging Face dependency instead, and you would configure like all that information from there. The basic like interfaces would still stay the same. This is a good page to just go and see like here's a list of all the different LLMs it supports, and there's a list.
So if I've got the safe tensors locally,
I'm sorry?
if I've got the model locally,
Yeah.
can I still link it?
Yeah, so if it's an OpenAI compatible API, you can just change the,
No, I mean the model itself.
yeah, I don't think it can interact directly with the model, but for instance, it supports OLLAMA and local AI and things that provide an API for local models, so you could do that. You can see that, for instance, local AI supports function calling, whereas like OLLAMA, these are both ways you can run models on your own computer. So OLLAMA doesn't support function calling. So you want to make sure that whatever model you choose supports the features you want. So in this case, we couldn't just go and pick any one right now if we wanted to do the exact same thing here, but we could use Anthropic for Claude, or we could use like Google Vertex or whatever. Yeah, so this is a super active project. There are 85 contributors. Like I was talking to somebody here that mentioned that like they have contributors from Google and Microsoft and all the kind of major database and like model creators. So this is a really active project. The downside maybe of LangChain4j is that it's very community driven, so there are like 4 APIs to accomplish every single thing, and it's like not always super clear like what you should use and when and how long is that API going to be around for. There's a newer project called Spring AI by the Spring team, which seems to be taking a much more conservative approach to this, so they are not nearly as kind of fully featured as LangChain4j is at this point. But also I think that like whatever they're building, they're building with the intent of they're going to maintain this for a good amount of time to come. So probably more conservative, but that can sometimes be a good thing in the enterprise world. The good thing is that there are options. There's also the Microsoft semantic kernel, which is kind of a port of a C# library, which is kind of takes a different approach to this, where it's essentially trying to mimic a Unix kernel, where the LLM is, or it has kind of a kernel, and then you can register different LLMs and agents and tasks to it, and then it tries to like, it goes much more further into that autonomous region if you want, so you can define a planner. So if you ask a question, it would first use the planner to make a plan for itself on like, given all the tools it has and all the models it has, like, at first I need to figure out this by calling that model, and then I need to sort out this by doing a Bing search. I guess it always was a Bing search, maybe, who knows. Anyway, so I've tried to add support for semantic kernel, but they recently just completely rewrote their entire API and didn't create any documentation yet, so it's been slightly difficult, but I'll try to get it in there, because it's a quite interesting kind of concept. What I noticed there though is that it's very kind of enterprise development with a capital E, so it's like there's a lot of boilerplate involved in getting started, but I think that probably is fine if you're doing a big long project where it's kind of warranted, but for a demo like this we'd be probably still be typing if we were using semantic kernel. All right, well, thanks so much for having me. I'll be sticking around for a bit, so if you have any more questions or anything, feel free to hit me up.